Hello everyone. In today's video, we are going to see what are one-to-one functions. In different books, there are different explanations to find out that the relation is one-to-one function or not. I am compiling all of them and presenting in front of you. Let's get started. What is one-to-one function? To check that whether the function is one-to-one, we should have for one input value, there will be only one output value. What is the meaning of that? Which means that for each value of the domain, you will get only one value of the range. Let's understand it with the first method when the graph is given to us. When the graph is given to you, draw the horizontal line and see it cuts the given graph at how many points. Let's see one graph here. This is the graph we have in front of us, which is the graph of y is equal to x plus 1, which is a straight line, as you can see that from here. I have to draw a horizontal line and see how many points it is cutting on the line. If I draw the line here, it touched the line here, and if I go down, I'll get the answer for my x value. If I draw another horizontal line here, it touches the graph here, and if I go down, I can find out my value for x. This shows that for one value of y, I am getting one value of x. Or you can say that for one value of x, I am getting only one value of y. That means one value in the domain will give you only one value in the range. Like you can see from here, f of 2.5 is equal to 3. This is my input value which is in the domain, and this is the range value which I am getting as 3. If I give minus 2.5 as a domain value or the x value, I am getting minus 1.5 as my y value in my range. Now this is called the one-to-one function. Now let's see the second method. In second method, when you have the mapping is given to you, as you can see from here the diagram, when the mapping or the function is given to you, there should not be any element left in the domain. These are the two sets you have, x and y. The elements of x are 1, 3, 8 and 9. The elements in y are a, b, c, d, e. This is your set x and this is your set y, and if the mapping is like this, 1 maps to A, 3 maps to B, 8 maps to C and 9 maps to D. As you can see from here, the different elements in the domain are mapped with different elements in the range, and no element is left over in the domain so that they should not have any image in the range. This is called the one-to-one function. Now let's see the third method. When we say that f of x is equal to f of y, if you can show that x is equal to y, then the given function is one-to-one function. Suppose we are taking one function like fx is equal to x square plus 5. What is the meaning of that? F of x is equal to f of y. That means I need to replace x with y and put them together as equal. My function is fx is equal to x square plus y. Let's write the function, the same function for f of y. Let's write down here. So f of y will be given by y square plus 5. I am replacing x by y. So here I have x which I replaced it with y. I have to put them equal. Let's put all of them equal here. X square plus 5 is equal to y square plus 5. I need to solve this and prove that x is equal to y is coming or not. Let's solve that here. 5 is got cancelled from both the sides here. You will get x square is equal to y square. If you take the root on both the sides, you will get x is equal to y. This shows that our function is one-to-one function. Let's see the fourth method. You can use this method only when you know the differentiation. Suppose the function is given to you is fx is equal to x square plus 5. What I have to do is I have to differentiate that function. Let's do the differentiation here. D by dx of fx will be given by d by dx of x square plus 5. This can be written as f dash x, which is equals to d by dx of x square plus d by dx of constant 5. That is equals to 2 x to the power 2 minus 1. Why? Because we know that d by dx of x to the power n is n x to the power n minus 1. Here my power is 2 here. So it will be 2 x to the power 2 minus 1. I need to differentiate the constant function here. So differentiation of constant function will be written as 5 multiplied by x to the power 0. As we know that x to the power 0 is 1. If I multiply x to the power 0 with 5, my answer is still 5. I need to differentiate that. 5 is a constant. Here my n value is 0 here. So it will be 0 x to the power 0 minus 1. Let's write down here. It will be 0 x to the power 0 minus 1. If you multiply any number with 0, your answer is 0. That's why the differentiation of the constant term is 0. So d by dx of the constant 5 is 0 here. If you solve that, that will be equal to 2x to the power 1, which is equals to 2x. After differentiating this function, I have to keep f dash x, which is the differentiation of x, I have to put it equal to 0. This will give you the critical point or the maximum or the minimum point. Let's put f dash x is equal to 0. I'll get 2x is equal to 0, which will give me x is equal to 0. This is my value for x. I have to check now for the value greater than the critical point and less than the critical point. Your critical point is x is equal to 0. I have to take one value lesser than that and one value greater than that. Let's take that when x is greater than 0, we are taking x is equal to 1 and substituting this in f dash x. What is our f dash x value? Our f dash x value is 2x. Let's substitute x is equal to 1 inside that. You will get 2 bracket 1 is equal to 2. You are getting greater than 0. 2 is greater than 0. As you can see from here, when I substituted x is greater than 0, my answer is 2, which is greater than 0. So both are greater than 0. This one I need to check it for the lesser than value also. Let's take x less than 0 and take the value as x is equal to minus 1. That I need to substitute in f dash x. F dash x is equal to 2x. Let's substitute the value here. I will get 2 bracket minus 1 is equal to negative 2, which is less than 0. You can see from here when I substituted x is less than 0, my answer is coming up minus 2, which is less than 0. So when you substitute greater than 0, your answer is greater than 0. When you are substituting less than 0, your answer is less than 0. That means your function is 1-to-1 function. This implies that whatever the critical value you have, if you are taking a value greater than the critical value, your answer will be greater than 0. If you are substituting the value lesser than the critical value, your answer should be less than 0. That's how you can check that your function is 1-to-1 or not. Thank you so much for watching. I hope you enjoyed my video. Don't forget to like, subscribe and leave a comment down below. Bye bye everyone.